So today we are simplifying radicals. So what we'll start with is this. You would see this as the square root of 36. So the first thing we always want to check before we start trying to simplify a radical is if it is a perfect square. The easiest way to do this is using our calculator. If you hit second, the blue second button, and then right here where it says x squared, see how above it's got that symbol, square root, and then we're just going to type the number 36. It is a perfect square, so at this point, we would say our answer equals 6, and that saves us a lot of time and effort. So let's go ahead and check the second one, example 2, square root of 72. So we're going to check it the same way, second, square root, 72. Notice it gives me a decimal. This is not a perfect square, so now I'm going to have to do the process to simplify this and leave it as a square root, not a decimal. So from here, what we do is we create a factor tree. You may have seen these in lower grades. We want to figure out what two things multiply to give us 72. There are multiple options. We're going to use 8 and 9. From here, we check to see, can 8 be split up any further? 8 can be split up into 2 and 4. What we're looking for is prime numbers, which means they can't be divided by anything but 1 and themselves. 2 is a prime number, so we circle it. 4, though, can be split up into 2 and 2. Like we just said, 2 is a prime number, so we're going to circle them. And now we go over to the 9 and we split it up. 9 splits into 3 and 3. 3 is a prime number, so we circle it as well. From here, we're going to take the original radical symbol, but we're going to make it a lot longer because we're going to write out all of our prime factors. And we're going to do it in order from least to greatest. So I have 2 times 2 times 2 times 3 times 3. Now remember, when we don't have an index or a number here, like we do over here, it is a 2. So what we're looking for here is pairs of the same number. So I have 2 2s and I have 2 3s. This 2 is all alone. We're just going to leave it there. So now, anytime you have a pair, we're going to bring it outside of this radical symbol. But when you bring it out, only one of them comes outside. So we brought 1 2 out from that pair, and we're going to bring 1 3 out from that pair. Now, that can't come out, so we leave it inside the square root as 2. Last step is we just simplify. 2 times 3 is 6, square root of 2. That would be our final answer. So now we're going to do example 5. We'll do 3 and 4 together in class. So notice there's no numbers here, so I can't check it on the calculator. So from here, I just have to write it out. So we're going to expand it out like we did a couple weeks ago. We're going to take x to the 5th power means we have 1, 2, 3, 4, 5 x's. Y to 6 means we have 1, 2, 3, 4, 5, 6 y's. Now once again, we don't have an index, so it means it's 2, so we're looking for pairs. Don't have a pair of that, so I go to the y's, pair of y's, pair of y's. So all the y's are paired up, and we just have this x left alone. For every pair, 1 comes out front. So we have a pair of x's, so we bring out one x. Then we have another pair, so we bring out another x. That x stays inside, so we bring out a y, another y, and one more y. From here, that x has to stay inside, so we leave it there. And now we simplify. X times x means x squared. Y means y cubed, square root of x. All right. Our last example we're going to do together on the notes is the cubed root of x to the 7th. So once again, we're going to rewrite this, but this time we have to remember to put that 3 there. We expand out the x's, so we have 7 of them. That's 3, 4, 5, 6, and 7. Now instead of pairs like up here, I'm going to look for groups of 3. Okay, so now anytime there's a group of 3, only 1 comes out. And now I rewrite my symbol with the 3. The x stays inside by itself because it was not grouped up. From here, we rewrite it to simplify. X times x is x squared, cubed root of x. That would be our final answer. And we'll do examples 3, 4, and 7 in class.